6 Polynomials, Subtopic 6.3 Partial Fractions. At the end of the lesson, students should be able to construct partial fraction decomposition when the denominators is in the form of, first, a linear factor, second, a repeated linear factor. So if you can see here, a linear factor which is repeated twice, and third, a quadratic factor that cannot be factorized. Next, we have to change rational polynomials to proper fractions when the degree of the numerator is the same or more than the denominator, and then determine the partial fractions. So if you look at the diagram, we have two types of fractions. The first one is proper fraction, and the second one is improper fraction. So if you look at the proper fraction, definition of proper fraction, when the degree of the numerator is less than the degree in the denominator. So what is the degree? If we can still remember, degree is highest power of x. Okay, so if you look at the example, 2x squared minus 7 over x cubed plus 1. In the numerator, the degree is 2, while in the denominator, the degree is 3. So degree in the numerator is less than the degree in the denominator. So 2x squared minus 7 over x cubed plus 1 is a proper fraction. So for 3, we have 3 times x power 0. So the degree is 0. And while in the denominator, the degree is 1. So the degree in numerator is less than the degree in the denominator. So this is a proper fraction. Third example, x squared. So the degree is 2 over x cubed plus 1. So the degree is 3. Degree in the numerator is less than the degree in the denominator. So this is also a proper fraction. And in the last example, we have 2x squared minus 7. So the degree is 2. X cubed plus 1. The degree is 3, and the degree in the numerator is less than the degree in the denominator. So this is also a proper fraction. Next, we're going to look at the definition of improper fraction. So what is improper fraction? When degree of the numerator is greater than or equal to the degree of the denominator. So if you look at the example, so 2x power 4, degree is 4. Over x cubed plus 1, the degree is 3. If you can see here, the degree in the numerator is higher than the degree in the denominator. So this is an improper fraction. In the second example, we have 3x cubed plus 7, so the degree is 3. Over 2x cubed plus 5, so the degree is also 3. If you can see here, the degree in the numerator is equal to the degree in the denominator. So this is also an improper fraction. So the first thing, if you want to decompose fraction into partial fraction, we have to identify if the fraction is a proper or improper fraction. So for proper fraction, there are few factors. The first one is a linear factor. So if you can see, like the example that we have here, so in the denominator, we have two linear factors, x minus 3 and x plus 1. So to decompose into partial fraction, first we have to decompose into general partial fraction. So 2x plus 5 over x minus 3 times x plus 1. If we decompose into general partial fraction, we're going to have a constant over x minus 3 plus a constant b over x plus 1. If we look at the first example for repeated linear factors, in the numerator, we have 2x plus 1. So 2x plus 1 is a linear. But x minus 3 squared is a repeated linear factor. Okay, so for linear factor, if we express the fraction into partial fraction, into general partial fraction, so for linear factor, we're going to have a constant over the linear factor. But for repeated linear factor, so if you look here, the linear is repeated twice. So for the first fraction, we're going to have a constant over the linear. And we have to, the second fraction is we're going to have another constant over the linear which is repeated twice. Okay, if we look at the second example, we have x squared x squared times x minus 7. So x squared is not a quadratic. It is considered to be a repeated linear factor. We repeat x twice. So this is repeated linear factor, while x minus 7 is a linear factor. So if we express 2 minus 3x over x squared times x minus 7, we're going to express it as a constant a over x plus b over x squared. This is for the case of repeated linear factor, plus for the linear factor c over x minus 7. Next, for the case of quadratic factor that cannot be factorized. If you look at the first example, x minus 1 over x times x squared plus 2x plus 2. So x is a linear factor, while x squared plus 2x plus 2 is a quadratic. A quadratic factor that cannot be factorized. If we can still factorize the quadratic, we have to factorize and we have two linear factors. But for this case, x squared plus 2x plus 2 cannot be factorized, so it is considered as quadratic factor. So when we express this fraction as partial fraction, we're going to have a constant a over the linear x, plus for the quadratic, we're going to have a linear factor. So, we're going to have a linear on top of the quadratic. So we have plus bx plus c over the quadratic factor, which is x squared plus 2x plus 2. For the second example, we have 2 over x squared plus 1 squared. So we have a quadratic that is repeated twice. And x squared plus 1 is a quadratic that cannot be factorized. So it is a repeated quadratic. So if we express as partial fraction, we're going to have a linear on top of x squared plus 1. So ax plus b over x squared plus 1. And since the quadratic factor is repeated twice, so we're going to have plus cx plus d over x squared plus 1 squared. Example 13 on page 15. Express 15 plus 34x minus x squared over 3x plus 1 times x minus 1 squared in partial fractions. So this fraction is a proper fraction since the degree of numerator is 2 while the degree of denominator is 3. Since the degree of the numerator is less than the degree in the denominator, so this is a proper fraction. So let's have a look at the factors in the denominator. 3x plus 1 is a linear factor, while x minus 1 squared is not a quadratic factor, but it is a linear which is repeated twice. Hence, it is a repeated linear factor. So first, we have to express the fraction in general partial fractions. So when we express the fraction in general partial fractions, for the linear factor, we're going to have a constant a in the numerator. And for the repeated linear factor, we're going to have plus b over the linear factor plus a constant c over the linear factor which is repeated twice. Next, we have to equalize the denominator. So we're going to have a times x minus 1 squared plus b times with 3x plus 1 times x minus 1 plus c times with 3x plus 1 3x plus 1 times x minus 1 squared. Next, we have to compare the numerator. So we're going to have 15 plus 34x minus x squared equal to a times x minus 1 squared plus b times with 3x plus 1 times x minus 1 plus c times with 3x plus 1. Then, to find the values of a, b, and c, we have to substitute few values of x. To speed things up, we're going to let x minus 1 equal to 0. So x equal to 1. And we're going to let 3x plus 1 equal to 0. So x equals to negative 1 over 3. So among the x that we're going to use x equals to 1 and x equals to negative 1 over 3. But since we have 3 unknowns, we only have 2x. So we have to choose another x to substitute into the equation. So when x equals to 1, substitute into the equations, we're going to have 15 plus 34 times 1 minus 1 squared equal to a. When we substitute 1 into the equation, we're going to have 0 plus b. When we substitute 1 into the bracket, we're going to have 0 plus c times with 3 times 1 plus 1. So if we simplify, we're going to get 48 on the left hand side, and for the right hand side we're going to have 4c. So c equal to 12. When x equal to negative 1 over 3, substitute into the equation, we're going to get 15 plus 34 times negative 1 over 3 minus negative 1 over 3 squared equal to a times with negative 1 over 3 minus 1 plus b. When we substitute negative 1 over 3, we're going to get 0 plus c. When we substitute negative 1 over 3, we're going to get 0. So simplify the equation. We're going to get 32 over 9 on the left hand side, and on the right hand side we have a times with 16 over 9. So a equal to 2. Next, we have to choose another x to be substituted into the equation. So we choose x equals to 0. When x equals to 0, we're going to get 15 on the left hand side, and on the right hand side we have to substitute 2 into a times 0 minus 1 squared plus b times 3 times 0 plus 1. So we get 1. 0 minus 1, so we have minus 1 plus c, which is 12, times with 3 times 0, 0 plus 1, so 1. So when we simplify the equation, on the left hand side we have 15, and on the right hand side we have 14 minus b. So b equal to negative 1. Substitute back values of a, b, and c into the equation. So 15 plus 34x minus x squared over 3x plus 1 times x minus 1 squared equal to 2 over 3x plus 1 minus 1 over x minus 1 plus 12 over x minus 1 squared. So that is our final answer. Example 15 on page 17. Change 3 over x plus 2 times x squared plus 1 in partial fractions. This is obviously a proper fraction. X plus 2 is a linear factor. x squared plus 1 is a quadratic factor, but it is a quadratic that cannot be factorized. So we have to express the fraction in general partial fractions. So 3 over x plus 2 times x squared plus 1 equal to, for the linear factor, we have a over x plus 2. But for the factor that cannot be factorized, we have plus bx plus 1 over, bx plus c over x squared plus 1. Since we have a quadratic in the denominator, so for the numerator, we should have a polynomial of degree less 1 than the denominator. Next, equalize the denominator. We have a times x squared plus 1 plus bx plus c times x plus 2 over x plus 2 times x squared plus 1. By just considering the numerator, we have 3 equal to a times x squared plus 1 plus bx plus c times x plus 2. In previous example, to find the values of a, b, and c, we substitute 3 values of x. But other than that, we can also find the values of a, b, and c by just comparing the coefficient according to the power of x. So we first expand the bracket. We have ax squared plus a plus bx squared plus 2bx plus cx plus 2c. Then rearrange the expression according to the power of x. So for x squared, we have a plus b. For x power 1, we have 2b plus c. And for x power 0 or constant, we have a plus 2c. Compare with the left-hand side. So for x squared, x power 2, on the left-hand side, we have 0. And for the right-hand side, we have a plus b. By comparing coefficient of x power 1, in the left-hand side, we have 0. And for the right-hand side, we have 2b plus c. And when we compare the constant in both sides, we have 3 equals to a plus 2c. Let a as subject, we have negative b. Let c as subject, we have negative 2b. So this will be our first equation. Second equation, and substitute equation 1 and 2 into 3. So 3 equals to negative b plus 2 times negative b. So we get negative 5b, hence b equals to negative 3 over 5. Substitute back b equals to negative 3 over 5 into equation 1 and equation 2. So substitute b equals to negative 3 over 5. So a equals to negative times negative 3 over 5. We have 3 over 5. When we substitute b equals to negative 3 over 5 into 2, we get c equals to negative 2 times negative 3 over 5. So c equals to 6 over 5. We already found values of a, b, and c. Then substitute the values into the general partial fraction. So 3 over x plus 2 times x squared plus 1 equal to, so for a, we have 3 over 5 x plus 2 plus bx, negative 3 over 5x plus c, 6 over 5 over the factor that cannot be factorized, which is x squared plus 1. So our final answer is 3 over 5x plus 2 plus with negative 3x plus 6 over 5 times x squared plus 1. So this is our answer. Improper fraction. If the degree of px is greater than or equal to the degree of dx, we have to do long division first. So px over dx is a improper fraction. If we use long division, we can express it as qx plus rx over dx. So rx over dx is a proper fraction. So we have to express in partial fractions, as what we learned in the previous videos. Example 16 on page 18. Express 2x cubed minus 7x squared plus 17x minus 19 over 2x squared minus 7x plus 6 in partial fractions. The polynomial in the numerator is of degree 3 and the polynomial in the denominator is of degree 2. The degree in the numerator is greater than the degree in the denominator. So this is an improper fraction. So for improper fraction, the first step that we need to do is to do long division. So the polynomial in the numerator will be px. The polynomial in denominator will be dx, the divisor. So 2x cubed minus 7x squared plus 17x minus 19 will be divided by 2x squared minus 7x plus 6. So to get 2x cubed divided by 2x squared, so we get x. So put x on top of the long division. X times 2x squared, we're going to get 2x cubed. So x times 2x squared, we get 2x cubed. X times negative 7x, we get negative 7x squared. X times 6, we get plus 6x. After multiply, we subtract. So 2x cubed minus 2x cubed, 0. Negative 7x squared minus negative 7x squared, 0. 17x minus 6x, we get 11x. Now bring down negative 19. So the remainder that we have is 11x minus 19, which is a degree less than the divisor. So we're going to start our long division here. Rewrite the fraction 2x cubed minus 7x squared plus 17x minus 19 over 2x squared minus 7x plus 6 equal to the quotient x plus 11x minus 19 over 2x squared minus 7x plus 6. So for the second term, we now have a fraction which is a proper fraction. So we're going to express the fraction as partial fraction. So 11x minus 19 over 2x squared minus 7x plus 6 is a quadratic that can be factorized as 2x minus 3 times x minus 2. So express this fraction in general partial fractions. We're going to have a over 2x minus 3 and b over x minus 2. Equalize the denominator. We're going to have a times x minus 2 plus b times 2x minus 3 over 2x minus 3 and x minus 2. By just considering the numerator, we have 11x minus 19 equals to a times x minus 2 plus b times 2x minus 3. Next, we have to find the values of a and b. By substituting two values of x, we're going to find a and b. So we can let x as 2 and x equals to 3 over 2. When x equal to 2, 11 times 2 minus 19 equal to a times 0, because 2 minus 2 is 0, plus b times with 2 times 2 minus 3. So 3 equal to b. Next, substitute x equal to 3 over 2 into the equation. So 11 times 3 over 2 minus 19 equal to a times with 3 over 2 minus 2 plus b. When we substitute 3 over 2 into x, we're going to get 0. So simplify, and we're going to get a equals to 5. So substitute a equals to 5 and b equals to 3 into the general partial fractions. So we can rewrite our original fraction, which is 2x cubed minus 7x squared plus 17x minus 19 over 2x squared minus 7x plus 6 as, don't forget your x plus 5 over 2x minus 3 plus 3 over x minus 2. So that is our final answer.